Hello science students. In the previous video we learned about the wavelength equation and that the wavelength of a wave is equal to its velocity divided by its frequency. Our goal in part 2 is to look at some examples of how to use that equation. So the goal is to be able to use the wavelength equation to describe a wave. And by describe a wave I mean we can now talk about its wavelength, its velocity, its frequency. If we have all three, we really have a good understanding of that wave. So the very first example, no background, just some numbers. So we know the frequency, the wavelength, and we're looking for the velocity. First thing we want to do is look at the equation. So we could use the wavelength equals velocity divided by frequency equation, or we can take a look at the triangle. I found that the triangle is sometimes a little bit easier to use because it eliminates the algebra steps for us. We're looking for the velocity, therefore I cover that up, so the velocity will be equal to the wavelength multiplied by the frequency. We could find this in exactly the same way over here by just simply multiplying both sides by frequency, and we still get, when the frequency is canceled out on the right side here, that the velocity is equal to the frequency and wavelength multiplied together. Now, since hertz is 1 per second, or 1 over seconds, and wavelength is in meters, it will give us velocity. So let's go ahead and see what that looks like. So our wavelength is 2 meters. So I plug that into the equation. Our frequency is 10 hertz, which is 1 over seconds. Meters times 1 over seconds is meters per second. So our units do match up, which is great. And 2 times 10 is 20. So this wave has a frequency of 10 hertz. It will pass by a given point 10 times in a second. It has a wavelength of 2 meters, and therefore it is moving at about 20 meters per second. That's how fast the wave is moving. Let's look at another example. Example number 2. This one's a little bit of a story problem. So that means we have to figure out what all this means. An ocean wave is moving at 8 meters per second. We can identify that relatively quickly as the velocity. It has a frequency, that's nice, they told us that that's what this number is, of 4 waves each second. What that means, it's 4 per second, 4 waves per second. So we actually have a frequency of 4 hertz. What is the wavelength? So we are trying to figure out what the wavelength is. Fortunately for this one, we can just use the original equation. Wavelength is equal to velocity divided by frequency. Our velocity is 8 meters per second. Our frequency is 4 hertz, or 1 over seconds. The 1 over seconds cancels out, leaving us with meters, which is good because that's the unit of wavelength. 8 divided by 4 is 2. So our wavelength for this wave is 2 meters. So if we have an ocean wave that's moving at 8 meters per second and passes by 4 times per second, its length is just 2 meters. Perfect. So another thing that could happen is they could tell you the height of the wave. That would be equal to the amplitude. Amplitude does not appear in this equation, so that would just be extra information. All we needed was the velocity and the frequency of 4 hertz in order to solve this problem. Let's look at one more example. To save us a little bit of time, I did not write a full problem for this one, but we want to look at a speed of sound problem. The speed of sound is 340 meters per second. The wavelength of our particular wave is going to be 2 meters. So we know our velocity is 340 meters per second. In air, it's about 343 meters per second. We're rounding it off just to make the numbers nice. And it does vary depending on the temperature and pressure of the air. So that's a nice round number for us to work with. The wavelength, they've told us, is 2 meters. And therefore, the missing piece of information must be the frequency. So let's see if we can figure out the frequency of this wave. Once again, we could use our wavelength is velocity over frequency equation, or we can look at the triangle. And since we're looking for frequency, I cover up the F, and we're left with velocity divided by wavelength. So frequency will be velocity divided by wavelength. Once again, we could figure this out. So if I multiply frequency over like before, and then divide by wavelength, we would get exactly the same equation using our algebra skills. Our velocity is 340 meters per second. Our wavelength is 2 meters. This means that the meters will cancel out, leaving us with 1 over seconds, which, as we've seen in the last couple problems, is the same as hertz. 340 divided by 2 is 170. And we can put our units of hertz. So a relatively high frequency of 170 hertz. Perfect. Thank you guys for watching these 3 problems. Hopefully they're helpful for you guys in trying to figure out different types of wavelength equation problems. Thanks for watching.